So now that we have the data imported, let's go ahead and plot it and take a look at what it looks like. There you go. So I've never been to Washington, but if you have, maybe you'll recognize the water body here. There's like a river running through these areas, and we're looking at land surface temperature. So you'll see that it's between just under 20 to quite a bit over 50 degrees, and it's a very clean 2D raster layer. So it's a regular grid, and you can see the latitude and longitude on the X and Y axis. So this is the data that we're going to be working with. Let's close that and experiment and practice working with this raster data a little bit more. So sometimes when you have a raster layer, one of the things you want to take a look at is the distribution of values. We see that the values are all here with a few missing values here in white. But sometimes you want to see what the distribution is. And you can do that very simply by using the hist function. Hist stands for histogram, and it'll pretty much take all the values in the raster layer and plot it in a histogram. So let's go ahead and take a look at the histogram. Okay, so here it is. It follows a pretty normal distribution. The range of values are down here, and the frequency is on the y-axis. So sometimes if you're working with air pollution data or some other type of environmental variable, you may create a histogram and it's not a normal distribution. Maybe it's skewed to the left or the right. And in that case, if you're running like a regression model, you may need to transform it so that it does follow a normal distribution, but that's beyond the scope of this course. And yeah, this is just a really easy way to visualize what your data looks like. Okay, so if you want to just look at the values as they are, the raw values, you use a function called values. So very straightforward, and you input the name of your raster, which for us is LST raster. It's just a way to visualize the raw raster data if that's what you need. And the great thing about having such easy access to the rasters is that you can really modify them or filter them as you see fit. So for instance, if you want to filter out a certain range of values, you can just do that directly within the raster. And I can show you what I mean. So let's pretend that we want to remove any temperatures that are less than 30 degrees. We can just reference the raster and then input a filter directly within square brackets next to the raster. We can use that as an index filter. So we want to remove any temperature data that is less than 30 degrees. So all we do is reference the raster again to create our index and then create the filter. So for us, this is what the filter looks like, less than 30 degrees. And I want to set values that are less than 30 degrees to NA, so not applicable. And then we can run that. Let's take a look at the raster again in the console. So LST raster, and you can see that the minimum value is 30 degrees, whereas originally it was much less. It was less than 20. Let's plot the updated raster with this filter applied. So you can see now that we don't have values that are less than 30, so a lot of the water bodies, which would have a cooler land surface temperature, have been removed and just replaced with white space, which indicates missing values. This is just one way to remove outliers if you know what your outliers are, or remove extreme values. So now that we know how to work with a raster and modify a raster, let's do some calculations and look at additional types of rasters. So up until now, we've been dealing with land surface temperature. Now in the next section, I want to work with a raster of NDVI, which is the normal difference vegetation index. This is a measure of greenness. The values range from -1 to 1. So 1 indicates a lot of vegetation, -1 indicates next to no vegetation. So I'm going to create a couple titles here. And the raster we want to import is in the data folder, and it's called ndvi underscore call underscore actual. Please excuse the strange file name, but that's what we're working with. So we're going to create a variable ndvi, and we can import the file. And this should be within quotation marks. Let's import that. Let's close this plot and import the raster. We can go ahead and just plot it again just to visualize it. There's our NDVI. So this is again for Washington. You can see the range of values is between -1 and 1 essentially, and most of Washington has a relatively high NDVI, and the water area has a very low NDVI because there's no vegetation, which makes sense. So if you know Washington, you can gauge whether this is accurate or not, but this is what we have.